Time loops are a fascinating concept that have intrigued both scientists and storytellers alike. They have captured our imaginations for centuries, appearing in countless myths and legends from different cultures around the world. We see them in movies, books, and TV shows, where characters often find themselves stuck in a loop, reliving the same day over and over. But could time loops actually exist in reality? Could the fabric of time itself allow for such phenomena? Could we travel through time, reliving the same moments again and again, altering our actions to change the outcome? Let's explore the science behind this intriguing idea, delving into the theories and experiments that scientists have conducted. Time travel has always been a dream of humanity, a way to bridge the gap between the past, present, and future. We long to journey through the annals of history to witness pivotal events, or perhaps even to change the course of our lives, making different choices along the way. Time loops offer a tantalizing glimpse into this possibility, a realm where the past and the future intertwine in an endless cycle, creating a continuous loop of experiences. While the concept might seem like something straight out of science fiction, there are intriguing hints within the fabric of our universe that suggest time loops might not be entirely impossible. Some theories in physics, such as those involving wormholes and the bending of space-time, hint at the potential for such phenomena. To unravel the mysteries of time loops, we must first delve into the nature of time itself, understanding its properties and how it interacts with the universe. We often think of time as a straight line, flowing from the past through the present and into the future. But what if time is not a river, but a circle? What if, instead of moving forward in a straight line, time loops back on itself? This is the central idea behind time loops. Einstein's theory of relativity revolutionized our understanding of time, showing that it is not absolute, but relative to the observer. Time can be stretched and compressed, warped by gravity and velocity. This leads to the possibility that under extreme conditions, time could be bent into a loop. Imagine a region of space-time where time is so distorted that it forms a closed curve. Anything entering this region would be caught in an endless cycle, repeating the same events over and over. This is the essence of a time loop. Black holes are among the most extreme objects in the universe. These enigmatic entities have fascinated scientists and astronomers for decades, pushing the boundaries of our understanding of physics and the cosmos. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. This immense gravitational pull warps space-time itself, creating a fascinating and terrifying phenomenon. Some scientists believe that black holes could hold the key to time travel and time loops. The idea that these cosmic giants could allow us to traverse different points in time is both thrilling and mind-boggling. At the center of a black hole lies a singularity, a point of infinite density and gravity. This singularity is where the known laws of physics cease to apply, presenting a mystery that continues to baffle scientists. Here, the laws of physics, as we know them, break down. The singularity's extreme conditions challenge our understanding of the universe and open up possibilities that seem like science fiction. Some theories suggest that time itself could be infinitely distorted near a singularity, potentially creating a closed time-like curve or a time loop. This could mean that time travel, at least theoretically, might be possible. Imagine approaching a rotating black hole. The immense gravitational forces would create a scenario unlike anything we experience on Earth. As you get closer, the immense gravity would drag you faster and faster, swirling you around like water going down a drain. The experience would be both awe-inspiring and terrifying. Theoretically, if you could survive the journey and navigate the singularity, you might emerge in a different point in space-time, perhaps even in the past. This tantalizing possibility continues to inspire both scientific inquiry and the imagination of storytellers. Another intriguing possibility for time travel arises from the concept of wormholes. Wormholes are hypothetical tunnels that connect two distant points in space-time. While they remain purely theoretical, their existence is allowed within the framework of Einstein's theory of general relativity. Imagine folding a piece of paper in half. Now imagine a wormhole as a shortcut through the fold, connecting two distant points on the paper. In a similar way, a wormhole could potentially connect two different points in time. The challenge lies in creating and stabilizing a wormhole, which would require exotic matter with negative energy density. While we have yet to observe such matter, its existence is not ruled out by the laws of physics. Cosmic strings, cracks in the fabric of reality. Cosmic strings are another hypothetical phenomenon that could potentially give rise to time loops. These are incredibly dense, thread-like defects in the fabric of space-time, remnants of the early universe. While their existence is still debated, some theories suggest they could warp space-time enough to create closed, time-like curves. Imagine a cosmic string as a crack in the fabric of space-time. As you approach this crack, time itself could be distorted, potentially looping back on itself. If you were to travel around a cosmic string, you might find yourself caught in a time loop, reliving the same events. While the existence of cosmic strings remains uncertain, their potential to warp space-time and create time loops makes them a fascinating area of research. Quantum mechanics, time travel on a subatomic scale? Quantum mechanics, the theory that governs the behavior of particles at the atomic and subatomic level, also offers intriguing possibilities for time travel. One such concept is quantum entanglement, where two particles become linked, even when separated by vast distances. Imagine two entangled particles, one sent into a time loop and the other remaining in normal spacetime. Changes made to the particle within the time loop could potentially affect its entangled partner in the present, effectively allowing for communication or even influence across time. While this is a highly speculative area of research, the bizarre world of quantum mechanics suggests that our understanding of time and causality might be far from complete. The grandfather paradox, unraveling the threads of time. The possibility of time travel, including time loops, raises a host of paradoxes, the most famous of which is the grandfather paradox. This paradox has intrigued scientists, philosophers, and science fiction writers for decades, as it challenges our understanding of causality and the nature of time itself. This paradox asks, what would happen if you went back in time and killed your own grandfather before your parent was born? The implications of such an action are profound and perplexing. Would you cease to exist? Or would the universe somehow prevent this from happening? Could you prevent your own birth? This question leads to a cascade of other questions about the nature of existence and the linearity of time. This paradox highlights the potential contradictions and inconsistencies that could arise if time travel were possible. It forces us to consider whether time is a fixed sequence of events or a more fluid and malleable construct. It suggests that there might be inherent safeguards within the universe, preventing us from altering the past in ways that create paradoxes. These safeguards could be natural laws or principles that we have yet to fully understand. Some possible resolutions to the grandfather paradox include the idea of parallel universes, where each decision or action creates a new, separate timeline. In this scenario, each possible outcome of a time travel event branches off into a separate timeline, allowing for multiple realities to coexist without contradiction. Alternatively, there might be a self-consistency principle at play, which ensures that any actions taken within a time loop are already accounted for in the timeline. This principle suggests that the fabric of space-time is self-correcting, weaving any potential changes into the existing timeline in a way that maintains consistency and avoids paradoxes. Time loops and the structure of the universe. The existence of time loops could have profound implications for our understanding of the universe. If time is not linear but cyclical, it challenges our perceptions of causality, free will, and the nature of reality itself. Imagine a universe where time is not a river, but a vast, interconnected web of cyclical moments. Our past, present, and future might all be intertwined, each moment influencing and shaping the others. Time loops could potentially provide a mechanism for the universe to remember its past and influence its future. Exploring the possibility of time loops pushes the boundaries of our scientific understanding, challenging us to question our assumptions about the nature of time, space, and reality. Conclusion: time loops, a journey into the unknown. Time loops remain a theoretical concept, a tantalizing possibility that dances on the edge of our scientific understanding. While we have yet to observe direct evidence of their existence, the laws of physics do not explicitly rule them out. The quest to unravel the mysteries of time loops is a journey into the unknown, a testament to our insatiable curiosity about the cosmos. As we continue to explore the universe and delve deeper into the fundamental laws of physics, we might one day discover whether time loops are simply a figment of our imagination or a breathtaking reality waiting to be unveiled.